Welcome back. This is day 90 for Geometry A. We're going to introduce circles. And what is a circle? Well, a circle is the set of all points in a plane equidistant from a center. Point. Now, what this means for us is that if I have a center point, let's say the point P, then that point is the same distance to every single point on the circle. Those are the radial lengths. And that P is so important that the circle is named by the center. So this is actually called circle P. Okay. Remember that when we did segments, we put a segment over the top of the two letters. When we do triangles, we put a triangle in front of it. This isn't like that. This is more like plane, where we write the word plane and then three letters that represent the plane. We write the name circle and then put the letter after it to indicate the center. And as I said, the radius is something that's unique. It's from that center to any point along the circle, and it's that same length. It is a segment, meaning it has endpoints. It's a fixed length with endpoints at the center and on the circle. When we talk about on the circle, we mean along the outside of the circle. And so this would be called, the radius is equal to AP with a segment over the top. There's another term called a chord. And a chord is a lot like a radius, but it's a segment. Instead of it stopping at the center part of the circle, it just goes to another point on the circle. So a segment with endpoints on the circle. Maybe we should say with both endpoints on the circle. So this would be called chord JK. And one of our very specific chords that we're all already familiar with is when I go from one point on the circle to another point on the circle. So it's a chord, but I specifically go through the center point of the circle. If it actually goes through the center, that has a different name. That's a specific thing. That's a diameter, which is a chord, which we've just defined up here, that contains the center point. Please note, since this is a video, you have the opportunity to stop this video and catch up with the writing and notes. So I'm going a little bit faster. And again, there's some more vocabulary coming in here, and it's going to feel like a lot at first, but we'll learn how they work later. This one is called a secant. And this one is a line or array. In other words, it's longer than just a chord that intersects a circle in two places. So for example, if I had this, it doesn't matter whether it goes through the center or not. If it extends beyond the circle on both sides or on one side, and it intersects at two places, that's called a secant. So this would be called secant AB, and then because it's a line, I'm putting the symbol on top to show it's a line. The next one is called a tangent, and this is where it's like a secant in the sense that it's a line, but instead of it meeting the circle in two places, it only meets the circle in one place. So it's a line that only intersects the circle in one place. And of course, if I were to put a point like, I don't know, A here, and this is center P, it's not enough for me to name that. I can't name it with one variable. So I'm going to have to add another point somewhere on there. It won't be on the circle, but that's okay. I'm going to call this tangent. Actually, no, let's do it this way. Let's go with AB line is tangent to circle P. AB is tangent to circle P. And in fact, that leads to this last point, which is the point of tangency. It's the point at which a tangent line intersects a circle. So for example, this same picture here, here's circle P, and the line is tangent at A. A is the point of tangency. All right, this is page 52. We'll be putting this in page 52 of your interactive notebooks. Page 53. So here's our center. And if I were to draw from that center a radius, and then another radius, bad drawing, I create an angle here. And because that angle is centered on the vertex is on the center of the circle, that's called a central angle. So this is an angle with a vertex at the center. And two sides that are radii. Radius ends in US, which is Latin. And when you do a plural of US, it's I, which is very strange, I know, radii. If I take that center, my vertex of this angle, so like if this is A, P, B, this would be angle A, P, B. And you remember when we name angles, we go from some point on the side to the vertex and then along the other side. That's why we name it with a P in the center there. And the central angle will always have this center of the circle as the middle point there. But an inscribed angle is different. It's as if I take this vertex and I pinch it and I drag it back so that although A and B may still be in the same places, I've dragged this back. It's not a very good drawing. P is still there, the center of the circle is still there, but now It's over here. The vertex of my angle is way over here. And so we're talking angle A to C to B. That would make it an inscribed angle. So inscribed angle, which means drawn, scribe, on the inside of the circle. It's like sketched on the inside. It's an angle with a vertex on the circle. And both sides are what? What do we call these things when they go from a point on the circle to another point on the circle? From a point on the circle to another point. I learned about those a moment ago. Those are called chords. And so an inscribed angle is made up of two chords that have a point of intersection on the circle to form this angle. And this is the inscribed angle. Whether we have a central angle or an arc, oftentimes what we're seeing is that they intersect the circle in two places, and thus we can describe not just angles with those two as endpoints, but we could also look at a portion of the circle that is marked by those two things. And when we take a curved part of a circle and give it endpoints, that's called an arc. So it's a portion of the circle the circle's edge defined by two endpoints on the circle. And the way I'll note this is there's a couple of different types of arcs, but generally it's got the endpoints, A, B. And remember that if I put a segment over the top, I'm saying that it's a segment. If I put a line over the top, I'm saying it's a line. And so similarly, if I put a curved section on top, I'm saying that it's the curved part. It's the arc from A to B, marked like this. There are two types of arcs. A minor, well, there's three types actually, minor arc and a major arc. A minor arc is when we do what we expect. It's an arc whose measure is less than 180 degrees. We use two letters to name it. So for example, the one we just talked about a moment ago, if I go from a point on the circle A and I take the shortest path possible to get to another point on the circle, in this case B, this is a minor arc because it's the shortest path from A to B. But if I were interested in taking the scenic route, I'd be creating a major arc. And the difference there is instead of me going from A to B, the shortest path, now I'd be saying, I want to take the scenic route. I want to go all the way around this way. And I'm still talking about a portion of the circle. It is an arc, but now it's a much bigger arc. It's bigger than 180 degrees. It's bigger than halfway, which is 180 degrees. And how do I tell my user that I want to go from A to B like this, but I want to go the long way? And the answer is I have to introduce another point along the way. So I have to then say, I want to start at A and I want to go to B, and it is an arc. But instead of going the short distance, the assumed one I'm talking about, I want to force you to go this way. I'm going to take that letter and put it in between. So it'd be arc AXB to force the idea that I'm going A through X to B. And this is a major arc, which means it's an arc whose measure is greater than, let's say, greater than 180. We name it it's really hard to read. We use 3 letters to name it. Every time we're talking about a major arc, we expect to see 3 letters, 2 as endpoints and 1 that describes the direction we go. So we've talked about less than 180 and we've talked about more than 180. What if it's exactly 180? Well, if we go exactly from A to B and they happen to be exactly 180 degrees apart, then this part of the circle that I'm talking about in terms of an arc is exactly half of the circle. That means it's a semicircle. So it's an arc of exactly 180 degrees, and the endpoints of the arc of semicircle are also endpoints of a diameter. Right? If I were to connect A to B, it would go right through that center. It would be a chord that goes through the center, calling it a diameter. And the endpoints of A, B would be the same endpoints as the endpoints of a semicircle. A couple of formulas to throw in your books. You already know about these probably. There are formulas for the area of a circle, which is area of a circle equals pi times r squared. And we'll play with that in a little bit. And what that describes is if I have a circle, it's all the stuff on the inside is the area. The circumference of a circle, on the other hand, is 2 times pi times r. And that's where we're talking about just the outside of the circle. Right? We're saying how long is it around the outside? And people often mix this up with degrees, because we know that all the way around the outside of a circle is 360 degrees, but that's not the circumference. The circumference is like if you had to walk this distance, how far would it be? And so that distance could be 3 inches, it could be 8 feet, it could be 100 miles. There's a length that describes the distance around the circle, and that's called the circumference. Now, an arc length refers to a portion of the circle. So for example, say I wanted to find the length of that little arc. It's not the whole circle, but it's close to that. So in other words, I'm going to take the entire length, the circumference, 2 pi r, but I don't want all of it. I want a fractional part. If this had been exactly half of the circle, I'd want half of the circumference. If this were exactly a quarter of the circle, I'd want 1/4 of the circumference. And so what the length is going to do is it's going to let me find it with the measure of the arc divided by 360. We'll talk more about what that means. This formula is a little premature, I think. We'll get into that next class. So what task I lay in front of you today as your homework, so to speak, is for you to name the circle's parts. Okay, these are all the terms we've talked about. And what we're looking at is what's given here. I want you to give it a name. So for example, if I look at LQ, here's L, here's Q. This is a part of a line. It's actually not a line, it's a segment, But how many times does it meet the circle? It meets it only once. So that means this is going to be a tangent with a point of tangency Q. So we would say tangent. And then like, what about X over here? That's the center of circle X. Okay, so fill this out, please. That's your work for today. When you finish that, if you want to take any of the unit tests because you're falling behind on those, you want to catch up. As you know, the videos are available for you to look at to see how to do them. And then when you're ready to take the tests, go on Go Guardian through your Chromebook and tell me. I'll be proctoring and I can open up the tests that you need for you. Hope you have a good day. Hope to see you guys soon.